Hi, I'm back today with Chapter 10 in Dr. Vaughn's book, The Power of Critical Thinking. Chapter 10 is Judging Scientific Theories. And we're going to look at science and the scientific method and how we leap from science to weird theories, things like crop circles and things like that. Most of what we're looking at today is, again, inductive reasoning. So we have to remember we're looking for probable evidence. We're looking for strong structure. And we're looking for cogent arguments, cogent truth. All of these things are important, and if you're a little unsteady on those terminologies, go back to Chapter 8 and do a little bit of review, okay? First of all, we're looking at, and we have to define what science is. And science is one of those terms that we throw around all the time, but most of the time we don't do it really well. So there are some things that science is not. Okay, so I have this little, science is not, it's not technology. Okay, science makes technology a lot of the times, but science is not the same thing as a computer. Science is not the same thing as even the probes that we send to Jupiter and Mars and all kinds of places. It's not the same thing as technology. Now, it informs technology, it creates technology, but it is not the same thing, okay? That seems fairly normal. Science is also, not ideology, okay? Now, an ideology is very similar in its ideas, similar in its definition to a worldview, except it's something that a whole group of people have. An ideology is a way of thinking about things. Now, science does, in a lot of ways, inform many ideologies, okay? Our look at our ethics and different things. A lot of that comes from what we know about how the world works, what we know about science. But ideology is not a worldview. It's not the same thing. And we can't identify science with a specific worldview, okay? So that makes it's not an ideology, okay? We have to keep that in our heads. The other thing is it's not scientism, okay? This is the important part there. Science, and I'm going to give you the actual definition here in just a minute, but science is not the end-all, be-all of figuring things out. There are other ways to figure out how the world works, especially when we're talking about processes and purposes and things like that. But with science, okay, science is a way of helping us understand about the world. Now, the exact one, because it's a big word, is on page 370, second line in that first real paragraph. An extremely reliable way of acquiring knowledge about the empirical world. Okay, so this is important to know. I don't want to mess it up for you. And all empirical means here has nothing to do with empire. It has to do with things we can observe, touch, taste, smell, that kind of stuff, okay? About the physical, empirical world, okay? And this is on page 370, right at the top. That's your big word, one of your big words, okay? Science is an extremely reliable way of acquiring knowledge about the empirical world. Now, extremely reliable because it's very systematic. Okay, it has rules. It's logical. We follow those rules very carefully. And so when we use science to explain how something works, we're doing very specific, very logical process. Okay, and so it's extremely reliable because we do it the same way all the time. Okay, you've heard that particular phrase a lot from me. But it's an extremely reliable way of acquiring knowledge about the empirical world. Okay, that's what science is. Now, when we do science, we're really doing the scientific method, okay? Now, this is one of those things that have been around since the Enlightenment, okay, so 1700s. And we're looking at, people have done this as far back as recorded history. We just didn't call it the scientific method yet. We have 5 steps, okay? So my scientific method, this is your other big word for this chapter. The scientific method has 5 steps, okay? First is, we identify the problem or we pose a question, okay? So identify the problem, the situation, the state of affairs, or ask a question. You've heard this as a research question. What do I want to know? What am I trying to find out? Okay, put it in the form of a question. It's the first step in the scientific method. Second, devise a hypothesis to explain this. Okay? Okay, so here's my problem, here's my question. What's the answer? Okay, what's a possible answer? And you have to basically go through all these steps for all the possible theories out there. Sometimes we give up pretty easily. Next is derive a test implication. Okay, test implication or prediction. This is how I expect this to come out. Okay, if this hypothesis is true, here's how I test it, and here's what I think I'm going to find. Okay, now a test implication, a prediction, is also a consequence. Okay, so kind of keep that in the back of your head when you're looking at all of these little things Dr. Vaughn's going to have you do. Okay. The fourth thing is actually perform the test. Sometimes the test is just an observation of a population. Sometimes the test is actually, something we do in a lab or a test tube or on a petri dish or whatever. But whatever that test is, go ahead and do it, okay? And then the last step is accept or reject your hypothesis. I would also say, and Dr. Vaughn adds this later on, or rework the hypothesis and try again. Sometimes when we get down here to number 5, we do the test and we get a consequence we didn't expect. Well, that doesn't mean that our hypothesis is wrong. Sometimes it just means that our test implication is wrong, our prediction is wrong. And so we can go back and retest and come up with a better or usually qualified hypothesis. Okay? We go from an all or nothing to a sum. That's an improvement with the hypothesis anyway. Okay? So here's our scientific method. For the big word thing, yes, I want the 5 steps. Okay, you need to be able to kind of rattle that off. Identify the problem, devise the hypothesis, derive a test implication, perform the test, accept or reject the hypothesis. Okay, or go back and try again. And I'm on page 370. Remember, when we're looking at theories, hypotheses, same thing. Okay. When we're looking at these theories or hypotheses, we have a special piece here we have to remember. This is top of 371. Theories generally reach beyond the known data to posit the existence of things unknown. And posit just means make an opinion, okay, make a prediction. So theories go beyond what we know to what we think is probably true. Straight, strict inference and inductive argument, okay? There are a couple of things we can think about when we're looking at our hypotheses and our test implications, okay? Just because, like I said before, the test implication doesn't work, okay? We get something else. Or when we get to this point and we do the test and we're wrong, okay? What does that mean? What does that do to our particular hypothesis? Well, it does a couple of things. Remember, back in chapter 3, and again in chapter 6, we had particular valid structures, okay? When we're looking at this kind of thing, we have the test implications, okay, my consequences, and they're going to tell us if our particular hypothesis is true or false, okay? Now, it can definitely give us an answer when our hypothesis is false, okay? And it looks like this. If my hypothesis is true, then C is the consequence. Okay, C will happen. My consequence will happen. Okay? C did not happen. So my hypothesis is not true. Too many things. Hypothesis is not true. Okay? We know we can do our little pieces here. So if I have if H, then C. Okay? If my hypothesis is true, then my conclusion is true. Not C, therefore not H. Okay? This, you will know right off the bat, I hope, this is a modus tollens. So we know that this is a valid structure. If this is how my test comes out, my hypothesis is not true. I need to revise it, or I need to come up with a better answer. Okay? So if my hypothesis is not true, if my consequence doesn't happen, then I'm done. Okay? I have to rework things. But if, well, let me fix this over. Okay. Here. Okay. If my hypothesis is true, then my consequence is true. Okay. Same thing. My C does happen. My consequence happens. Therefore, my hypothesis is true. Okay. Now, when we look at this, we know this is a confirming the antecedent. This is an invalid structure. Okay? So, if my consequence happens, I cannot say definitively, okay, conclusively, with my little idea of a deductive argument here, that this is true. Now, I can say it's probably true, but then that gets rid of this whole if-then stuff, right? I'm living in the realm of inductive argument here. So I know this gives me one more step closer. I have to do another test, or I have to show my evidence in other ways in order to continue to prove that my hypothesis is actually true. This is where most of our current theories live, okay? It's invalid deductively, but it's still a good argument inductively. And I know, mixing the two is kind of a bad idea. This works really well. If my hypothesis is not true, then my conclusion, my consequence will not be true either. And then I'm done. If it is true, I'm nowhere near done. Okay, I don't have facts here. I have inductive argument. So I have to be careful. Okay. But that's just that's what you should see here on page 371, 372. No hypotheses can ever be conclusively proven, okay, because it's hypotheses. If we could prove it, it's fact, okay? Gravity's a fact. The Big Bang theory is still a hypothesis. So we have those differentiations there, okay? Now, we have a lot of really good pieces here in chapter 10. Dr. Vaughn walks through some very prominent ideas, the difference between a Copernican universe and a Ptolemaic universe, the difference between creationism and evolution and intelligent design, how those things all kind of lay out theory-wise. And it's good to remember our criteria of adequacy, because we're going to use that all the way through to chapter 11, okay? Remember, we have testability, fruitfulness, scope, simplicity, conservatism. If you need a refresher on that, pop back to chapter 9. But that's going to follow in very carefully here on bottom of page 376, top of 377. And then he's going to walk us through some really good examples there. The second part of chapter 10 talks about, oops, let me back it up. In medicine, we have two different kinds of tests, okay, basically written. One is interventional, okay, we're actually going to give folks or run the simulation, we're actually going to observe how a particular medication or procedure works on particular people, okay, that's intervention. Non-intervention is basically a population study. We're going to see, with this huge number of people, what differences in their diets or exercise or geography or genetics. We're going to look at things that are already there. Okay, we're not going to actually set up a study and say, here, you guys do this stuff and you guys do that stuff. A non-interventionist study is usually how we start to make theories about what causes certain things, like what causes type 2 diabetes. Okay, when we look at population studies, different geography groups, different DNA groups have a lesser result of type 2 diabetes. In the United States, it's almost epidemic. Okay, with older adults especially. So how do we figure out what the tipping point is? And so there have been years and years and years of non-interventionist studies done to see which diets are better at not producing diabetes. Same thing with heart disease and high blood pressure and all this other fun stuff. And those are non-invasive. Okay, we're not asking people to take drugs. We're not asking them to go through these procedures. We're just looking at what they're doing already. Okay, and how that kind of stacks up against people who get this disease more often. When we're talking about an interventionist study, we're really talking about a double-blind initiative study. And double-blind just means that the folks in the study, the actual patients doing their work, and the docs and folks who are observing them, neither one knows who got the real drug and who didn't. Okay, and that's really the only ethical kind of proper way to run one of those kinds of studies. It's a double-blind. The people involved don't know, and the people observing don't know. Excuse me. And so when we're looking at different kinds of tests, they're not all petri dish, laboratory, those kinds of studies, invasive studies. Sometimes it's just watching what's already going on and making hypotheses about why it works or why it doesn't. Okay, science and weird theories. There are lots of folks out there that have all kinds of conspiracy theories. There are also folks out there who think about the way things work a little bit differently than how most scientists think about things work. And that doesn't mean that they're not right, just means that it's not scientific, okay? Now, for those of you who are folks of faith, please pardon Dr. Vaughn's kind of poke at anything having to do with the spiritual nature of things, or psychic phenomena, those kinds of interesting things, supernatural things. He's not having any of that. Now, what he's looking at, though, is strict scientific logic. Okay, so you have to kind of give him his break there. And one of the big questions in this area is, why should we bother understanding or even looking at these quote-unquote weird theories? And at the bottom of page 392, he gives us a good explanation. And I'm just going to kind of read back and forth on it. He says, why should we evaluate these claims in the first place? Well, for one thing, they are widely believed by a lot of folks, even really intelligent thinking folks. And on page 393, he gives you some pieces there. 60% agree that some people possess psychic powers or ESP. 42% of Americans believe in haunted houses. 38% believe in ghosts. 26% believe in witches. 28% believe in astrology. And these are these are big numbers, right? A quarter of the population believes in astrology, and ghosts, and things like that. And so because so many of our compatriots do believe, we need to be able to give an answer, basically. They're widely believed by the population and often difficult to ignore. Folks who really believe, they really believe, okay? And the claims in things like politics and medicine and many other fields can dramatically affect people's lives, for better or for worse, okay? It's important then for anyone confronted with such popular and influential claims to be able to assess them carefully, okay? So if you really care whether an extraordinary claim, and that's anything that's outside the realm of logic and science, is true or false, then critical thinking is going to be your best bet, going to be your best guide, okay? So how do we get these weird theories in the first place? Well, people make some weird mistakes. One is we tend to like things that are sensational and amazing. And so we make the jump to the weirdest theory, okay? When people have an extraordinary experience, they try to make sense of it. And a lot of times, science, logic can't really explain things to people's desires, okay? They can't give us things that we really, really like to hear, okay? But if we believe that just because we can't find or can't think of a natural explanation, doesn't necessarily mean there isn't one, okay? And this is at the top of 395. The other one, mixing what seems with what is. Remember, our perceptions can be fudged, okay? Our perceptions can be limited to what we can understand. This is especially true if we've been through a traumatic event, if we've been, say we've imbibed a little too much alcohol, if we're really tired, sleep deprivation, and I know you guys all feel this at this point in the semester, can make us perceive weird things, okay? Mixing what seems with what is, okay, thinking that just because something seems real, it is real. Now, the sideways to that is we can trust our own personal experience unless we have good reason to distrust it. Remember back in chapter 4, we're talking about ways that we can get messed up on that. One is the length of time since we had the experience, especially if we had that experience when we were a child. Not that, you know, children are not reasonable, but our understanding when we're 5 is very different than our understanding when we're 15 or 50. And looking back, we have to remember we're understanding this as if we were 5. Okay, so that gives us some limit there. Sometimes we misunderstand the possibilities. This has a lot to do with our own background knowledge. There are certain things that we don't know enough about to make a good claim for. In that case, we should defer to the experts. Misunderstanding logical possibility and physical possibility. Just because something makes sense to go from step A to step B to step C doesn't mean it's physically possible for that to happen. We're doing a lot of leaping there, and sometimes we have to be careful, okay? When we're judging weird theories, we actually have to walk them through the same process as if they were a legitimate theory, as if they were a scientific theory. We have to state the theory and check for consistency. Does it contradict itself? Does it actually explain the things that we're trying to explain? Okay? And then assess it, okay? Look at the evidence. Look at how it's put together, who said it, all those wonderful things. Look at alternative theories. Okay, and this is the hard part. When there's something extraordinary that happens, we tend to want the explanation to also be extraordinary. And sometimes it's pretty mundane. And it's disappointing in some ways. Test the theories with the criteria of adequacy. Go through testability, fruitfulness, scope, simplicity, conservatism. See how it stacks up to the other theories. It doesn't get a break just because it's extraordinary. Okay, so we have to keep that in mind. And then Dr. Vaughn walks through some interesting ones: crop circles, and goes on and on and on. Talking with the dead, those kind of ESP and psychic readings and things. And then walks it through the criteria of adequacy, uses our little table. Okay, so weird theories don't get a break just because they're weird. Don't get a break because they're extraordinary. They have to be evaluated just like we evaluate everything else. Okay, so walk it through the pieces. The criteria of adequacy is a big deal. You should be able to explain all 5 of those particular criteria: testability, fruitfulness, scope, simplicity, conservatism, so that you can use them pretty easily in not just for tests and things, but everyday stuff. Okay. When you're looking at the homework for Chapter 10, once again, please, please, please make sure you read the directions completely. Mark them up if you need to. I need to do 5 things in this. I need to do 3 things in this. And make sure that you're answering all the parts of the questions. Okay? Some of these directions are going to show up exactly as they are on the test. Okay, so it's good to figure out your directions ahead of time. And we'll look at the study guide and stuff once we get done with Chapter 11. Okay, so happy day. 28 minutes. I'm going to make things go away on my computer so I can get to this.